Okay, now we are moving to scheme of work for question 4, assignment 1. Okay, referring to the question 4, the description of the question is a system with a substance of CO2 initially at 2 kg and pressure 1 bar as well as temperature 27 degrees C undergoes a process at constant volume to P2 greater than P1, and then at state 2 the carbon dioxide is then expanded polytropically with PV power of 1.28 goes to constant, and at state 3 the process of constant pressure compression to the initial pressure, which means that this process is cycle process because it's back to its initial state. Assuming the carbon dioxide is ideal gas, so you can use EOS equation, and neglecting kinetic and potential energy. So you need to show the cycle on PV diagram, complete the energy table for Q and W, and lastly you need to compare the thermal efficiency if the pressure is pressure of state 2 is changed from 2 bar and then 3 bar, as well as the final is 4 bar. So discuss your findings. Okay, from this slide you can see I put the cycle process from 1 to 3 back to 1, and it is useful for us to clearly represent the whole process if we make the flow of the process from initial to the final, so that we know what the formula that we need in order to answer the question. Okay, and then we need to find Q and W for each process, starting from process 1 to 2, the energy balance by neglecting the KE and PE. So the energy balance will be Q minus W equal to delta U, because of the process 1 to 2 is constant volume, so there is no work done on the system or by the system, so the remaining will be Q equal to delta U, and then we can expand delta U equal to U2 minus U1, and we also can derive the internal energy into EOS equation, so that we get Q equal to mCV delta T. Okay, because of we only have the information on the initial temperature, which is T1, so we need to find the T2 using EOS equation. So from PV equals to MRT, rearranging the formula, we will get PV over T equal to MR. Since the constant volume, so the formula remain as P1 over T1 equal to P2 over T2. So you can get T2 equal to P2 over P1 multiplied by T1. Okay, next process 2 to 3, which is the process of expand the CO2 gas polytropically. So the formula for work boundary equal to MR T3 minus T2 divided by 1 minus N, which is N cannot be equal to 1. So in order to find that T3 equal to T2 multiplied by P1 over P2 power of N minus 1 over N. So we can have the Q minus WB equal to delta U, and Q equals to delta U plus WB that we calculated in the formula as shown above from this formula. Q minus WB equal to delta U. Okay, lastly, process 3 back to state 1, which is isobaric compression. We have the formula of WB equal to mass multiplied by the integration of PDV from state 3 to 1. Expanding the integration, we have mass multiplied by P3 V3 minus P1 V1, and PV can be replaced by the formula of MRT. We already have the temperature T3 and T2, and we have gas constant and mass, so we have the we can determine the work boundary for process 3 to 1. Okay, lastly, you need to compare the efficiency between 3 different P2, which are 2, 3 and 4 bar, and then you can see the effect of pressure to the efficiency. The efficiency is calculated by total W over Q in. Okay, that's all for question 4. Thank you.